Why are transient heat loads challenging for cooling systems? Imagine a machine suddenly working at full throttle, then slowing down just as quickly. That quick change in heat output can cause real headaches for cooling systems. When heat loads change rapidly, it's called a transient heat load. These are tricky because most cooling systems are designed to handle steady, predictable heat levels. But when heat spikes happen suddenly, it throws off the system's balance. Cooling systems have something called thermal inertia. This means they take time to respond because they store heat in their materials. If a component suddenly heats up, the cooling system can lag behind, causing temporary overheating. This delay can lead to damage or reduced lifespan of parts. It's like trying to fill a bucket with a slow faucet when a sudden leak drains it faster. The system struggles to keep up. During transient events, heat generation can jump well beyond what the cooling system can handle normally. Systems designed for steady heat might not be able to dissipate this extra heat quickly enough. This results in temperature surges that can harm sensitive components. Think of a computer processor suddenly working on a heavy task. Its temperature can spike in seconds, risking overheating if the cooling isn't fast enough. Many cooling methods like heat pipes or liquid coolants have their own limits. For example, heat pipes relying on capillary action to move heat. If the heat input exceeds their capacity temporarily, they can dry out or stop working efficiently. Phase change materials, which absorb heat during melting, can act as buffers but only if designed properly. Their effectiveness depends on surface area, thermal conductivity, and melting temperature. Materials used in cooling systems also matter. They have specific heat capacities and conductivities. If a material cannot transfer heat fast enough, it becomes a bottleneck. Proper design involves balancing these properties to handle both steady and transient loads. For instance, phase change materials can absorb large heat amounts during melting, but only if they are in contact with the heat source properly. Controlling transient heat loads requires precise management. Active cooling systems like pumps or fans need to respond quickly without causing oscillations. If they overshoot or respond too slowly, temperature fluctuations can occur. This can lead to instability or even system failure. Engineers must carefully design control systems to react in real time. If transient heat loads are not managed well, it can cause serious damage. Overheating can degrade materials, weaken mechanical parts, or cause electronic failure. This is especially true in high-heat flux systems or devices with tight temperature tolerances. For example, in aerospace engines or power electronics, even brief overheating can be catastrophic. In real-world applications, managing these challenges is vital. Electronics like computers or servers experience variable workloads that cause rapid temperature changes. Automotive engines during acceleration generate heat spikes that need quick dissipation. Compact cooling solutions like vapor chambers or heat pipes must be designed to handle these cycles without losing performance. To deal with transient heat loads, engineers often use thermal energy storage materials like phase change materials. These can absorb sudden heat spikes, preventing immediate temperature rises. They also design cooling surfaces with more area or better heat transfer features. Advanced control systems that adjust cooling rates on the fly are also common. Early consideration of transient thermal behavior is key. Relying only on steady-state assumptions can lead to failures when sudden heat changes occur. Proper design involves understanding how heat moves during these short, intense periods. This way, systems stay reliable, safe, and long-lasting even when faced with rapid temperature swings.